It's resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to S. Chand Academy, the official YouTube channel of S. Chand Publishing. So we have the book Mathematics for IIT-JEE Main and Advanced by ML Khanna Sir and videos by me, Subuh Nadeem. In this particular chapter, we are going to do properties of triangles. So this is chapter number 15. In this chapter, we are going to apply many of the concepts of a triangle. First, let us discuss some of the very important concepts. First is sine rule. Sine rule says that in a triangle ABC, where capital A, capital B, capital C are the angles of the triangle, and opposite to them are the length of the sides small a, small b, small c. So we write it as A by sine A is equal to B by sine B is equal to C by sine C, and further it is equal to 2 capital R. Capital R is the circumradius, that is the radius of the circumcircle. If we draw a circumcircle, then its radius is the circumradius. Then this is called capital R. This is the sine rule. Next we have is cosine rule. In a triangle, cosine rule is stated like this, that cos of an angle A is equal to B square plus C square. That is, these are the adjacent sides B and C, minus A square, the opposite side, upon 2BC, the adjacent sides. Similarly, if you want, you can write cos B. Similarly, if you want, you can write cos C also. So cosine rule can have 3 formula. Next we have Napier's analogy. What is Napier's analogy? Napier's analogy says that tan of A minus B by 2 is equal to A minus B upon A plus B. These are the sides into cot C by 2. Similarly, you can make the formula for tan B minus C by 2 and tan C minus A by 2 also. Projection rule. What is projection rule? Projection rule says that in a triangle ABC, let us take this triangle A, B, C. We have, suppose, A. So A side can be written as B cos C plus C cos B. How can we write this? It is not so difficult to understand. Let us drop a perpendicular from A on BC. So this portion is actually, this is B side, so this is B cos C. And if we talk about this portion, this is C side, so this is C cos B. So if you add B cos C and C cos B, you will get the whole length BC, which is A. Similarly, you can write for B, that is C cos A plus A cos C. Similarly, you can write for C, A cos B plus B cos A. So here again there are 3 formula, and if you remember any one, similarly other 2 can be remembered. Next we have is half angle formula. So in half angle formula, we start with sine A by 2. This is equal to square root of S minus B into S minus C upon BC. And what is S? S is the semi-perimeter here. This is a small s, and a small s is A plus B plus C upon 2. Similarly, you can write the formula of sine B by 2 and sine C by 2 also. What about cos? If we talk about cos A by 2, this is square root of S into S minus A upon BC. Again, S is the semi-perimeter. So let me write the name also. It is semi-perimeter. You will get this detail in the book also in the form of theory. What is tan A by 2? So it is sine A by 2 by cos A by 2. So this will simply become S minus B into S minus C upon S into S minus A. So these are the three formula. For each one you can form two more formula, because for cos B by 2, cos C by 2 also you can form a similar formula. Similarly tan B by 2 and tan C by 2. Now there are few formula about in radius. What is the in radius? In radius is the radius of the in circle of a triangle. So this is the in radius R, and this in radius is given as triangle area but above semi perimeter. So triangle area is I am denoting by triangle, but in book, since in typing you can write capital S and small s differently, so in book it is given as capital S by small s. So this capital S is nothing but area, and this small is nothing but semi perimeter. But I am using triangle to denote area here, in order that you don't get confused with capital S and small s. So I am using triangle in place of capital S, which is the area. But in the book you will find capital S as the area and small s as the semi perimeter. So from here again some more formula are there, that R is S minus A tan A by 2, or S minus B tan B by 2, or S minus C tan C by 2. So similarly we have formula for x radii also. What is x radii? In a triangle, if we extend these two sides, this side and this side, and we form a circle which is touching these two sides externally and this third side internally, this is a circle. So this is touching this in between the angles, and this side after producing. So if this is A, this is B, this is C, then this is called R1, which is the x radii. So x radii R1 is there. So R1 is equal to triangle upon S minus A, because it is opposite to A angle, the internal bisector of angle A and external bisector of angle B and angle C. So again I am using triangle. You may find capital S in the book. This is same as S tan A by 2. Similarly, if you get the x radius of R2 that is opposite to the angle B, you will find it as triangle by S minus B is equal to S tan B by 2. Similarly, R3 is equal to triangle by S minus C is equal to S tan C by 2. So these are some more theory about in radius and x radius. So we have plenty of concept and formula right now to start doing some questions based on this from the book. And don't forget to like, subscribe and share the channel with your friends, and also hit the bell notification to get all the upcoming videos notification. So this is the first question. In a triangle ABC, if A is equal to 3, B is equal to 4 and sin A is equal to 3 by 4, then angle B is equal to. Now basically this is a simple question. We are starting with a simple question, and here we have to apply sine rule. So what we will do, we will write as A by sin A is equal to B by sin B. And if we do this, A is given as 3, the side length. Sin A is given as 3 by 4. So let us write sin A, which is 3 by 4. B is given as 4, and this is sin B. This is sin B is equal to 3 into 4 by 3 into 1 by 4, which will be 1. So you can say that angle B is actually equal to 90 degree. So angle B is equal to 90 degree. In the next one we have the angles of a triangle are as 1 is to 2 is to 7. So we can say that this is A angle, this is B angle, this is C angle, and it is the ratio of the angles. Then the ratio of the greatest side to the least side. That means C upon A, greatest side by least side ratio, you have to find it out. So first of all what we can do, we can assume that A is equal to K, B is equal to 2K, and C is equal to 7K. Now if you add all these angles, you will get 10K, which should be equal to 180 degree by angle sum property of a triangle. So this will give you K is equal to 18 degree. Now if K is equal to 18 degree, C by A, which we have to find, is nothing but sine C by sine A by sine rule. So we say that sine C is sine 7K, sine 7 into 18 degree upon sine A is sine 18 degree. Now this is sine 126 degree upon sine 18 degree, and sine 126 degree by allied angle formula is sine of 180 minus 54 degree, which will finally become sine of 54 degree. So this is sine 54 by sine 18. Now in trigonometry we studied some important angles, sine, cosine and tan. So these are some of the important angles other than 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. What was sine 54 degree? You can see the derivation also. So this is root 5 plus 1 by 4, and this sine 18 degree is root 5 minus 1 by 4. So this will become root 5 plus 1 by root 5 minus 1. So you need to remember these important angles, sine. So this is root 5 plus 1 by root 5 minus 1. Hence it is proved. So if you say sine 18 degree is root 5 minus 1 by 4, you can also say this is cos of 72 degree. If you are saying sine 54 degree is root 5 plus 1 by 4, you can also say this is cos of 36 degree. And this will also help you in finding other some of the angles like sine of 54 degree or sine of 72 degree. If this is the next question we have, if cos A plus 2 cos C by cos A plus 2 cos B is equal to sine B by sine C, then the triangle ABC is either isosceles or right angle. This is what we have to prove here. So let us cross multiply. This I am multiplying here, this I am multiplying here. So cos A sine C plus 2 cos C sine C is equal to sine B cos A plus 2 cos B sine B. In the next step, you can take this one and this one on one side, and you can take cos A as common. So this will become sine C minus sine B, and these two terms on one side, and also you can apply the formula that 2 sine theta cos theta is sine 2 theta. So this will become sine 2B minus sine 2C. Now what is sine C minus sine D? Do you remember this is 2 sine C minus D by 2. So it will be B minus C into cos C plus D by 2. So it is B plus C. So this is cos of A into sine B, sine C minus sine B can be written as sine B minus sine C with a minus sign outside. Now cos A, what is minus cos A? So minus cos A is actually equal to cos of 180 degree minus A, which is actually cos of B plus C. So cos of B plus C can be written as minus cos A. So here we are keeping minus cos A as it is. This is sine B minus sine C is equal to 2 sine B minus C, and cos of B plus C here is equal to minus cos A. So this is minus cos A. Now this minus and minus will cancel, and both of them we are taking on the one side, and cos A will be common. So this will become sine B minus sine C minus sine of B minus C is equal to 0. So one thing which is coming out from here is cos A could be 0. So we can have cos A is equal to 0 here. Or another thing is that this term is 0, which is sine B minus sine C minus sine of B minus C is equal to 0. So if cos A is equal to 0, A is equal to 90 degree. So this is a right angle triangle. So this first thing we have proved that it is a right angle triangle. Now another thing which we have to prove from this condition is this is isosceles. So let us try to prove that also from here. So here we apply sin B minus sin C, the formula sin C minus sin D. So that will become 2 sin C minus D by 2 into cos C plus D by 2 formula. And sin B minus C here will be 2 sin B minus C by 2 into cos B minus C by 2. This is equal to 0. Now 2 sin B minus C by 2 will be common. 2 sin B minus C by 2 will be common. It will be cos B plus C by 2 minus cos B minus C by 2. So another thing which is coming out to here is 2 sin B minus C by 2 is equal to 0 is another option. That is sin B minus 2 is equal to 0. So this is 0 means that the angle is 0, which means B is equal to C is another possibility, which means that triangle is isosceles triangle. Now we are not going into the solution of this. If something else could have come other than right angle or isosceles, we could have got from here, but it is not asked. So we are not going into the more calculation. So we have already proved that it is a right angle or isosceles triangle. That is either angle A is 90 degree or angle B and angle C are equal. Next question we have, CF is the internal bisector of angle C of triangle ABC, then CF is equal to. So the figure is something like this, that it is a triangle ABC and CF is the internal angle bisector of triangle ABC. So this is F, this point. Now it is asked CF is the internal, then CF is equal to the length of CF is asked. So here what we can do is, let us take the area of triangle ABC as area of triangle ABC. This is made up of two area of triangles. One area is triangle ACF, another is triangle ABCF. Now if we add them, we get the whole area of the triangle. Now area of triangle ABC, if you want to find, that is half into AB into sin C by the formula of area of a triangle. Triangle ACF you want to find, that is this is small triangle, then that will be half into, let us take this side CF and this side which is actually B, into sin C by 2, which is this angle. Similarly, triangle BCF will be half into CF, this side, and this side A, into sin C by 2 again, that is this angle. Because both is C by 2, it is internal angle bisector. So half let us get cancelled, and from here AB sin C is equal to, CF is common, B plus A sin C by 2. So in the next step, CF is equal to AB sin C upon B plus A sin C by 2. Okay. Now we know that sin C is equal to 2 sin C by 2 into cos C by 2. So this is 2AB sin C by 2 into cos C by 2 upon A plus B sin C by 2. So sin C by 2 will get cancelled and you will get 2AB cos C by 2 upon A plus B. So 2AB by A plus B cos C by 2, option A is the correct option. But here one more option is correct, which is that C option. So we need to check. Now what am I doing? I am taking this triangle BCF. I am taking triangle BCF. In triangle BCF, it is applying sine rule. How will we apply sine rule? Let us suppose this angle is theta. So this angle is pi minus theta. So A upon sine pi minus theta is equal to CF upon sine B. This is how we can write it. And this implies CF by sine B is equal to A upon sine pi minus theta is sine theta by allied angle formula. So sine pi minus theta is equal to sine theta. And this sine theta, where theta is this angle, is actually B plus C by 2 by exterior angle property. So this is sine of a triangle B plus C by 2. So this sine theta, sine pi minus theta, which changes into sine theta, can be written as sine B plus C by 2. So this implies CF is equal to A sine B by sine B plus C by 2. Now A sine B can be written as B sine A. So this is B sine A by sine B plus C by 2. So B sine A by sine B plus C by 2, which is option number C, is your correct option. So this is another proof. This you have proved, and this also you have proved. So after this question where two options were correct, and it will always be mentioned whether it is multi-correct or not, we will see whether other options are correct or not. So here there is a next question. The sides of a triangle are 3 consecutive natural numbers and its largest angle is twice the smallest one. Determine the sides of the triangle. So what it is given, that in a triangle ABC, the sides are in arithmetic progression, 3 consecutive natural numbers. Not only arithmetic progression, but they are 3 consecutive natural numbers. N belong to natural number. And its largest side is twice the smallest. So largest side is n plus 2. So largest angle is angle C. So sine C, not sine C, that C, only C, is twice of smallest one, that is A. This implies if you take sine both the sides, sine C is sine 2A, which will give you sine C is equal to 2 sine A into cos A, right? So after doing this, you can apply sine rule and cosine rule simultaneously. So sine rule, this will become C, this will become A by 2r, and 2r will get cancelled, and cos A will be B square plus C square minus A square by 2BC. So 2 and 2 will get cancelled. Now let us cross multiply. So BC square is equal to AB square plus AC square minus A cube it will become. In the next step, what am I doing? I am taking this and this on one side and taking common C square. So this is B minus A. And this I am taking one side and I am taking A common. So B square minus A square. So B minus A will cancel from both the side. It will become C square A into B plus A, as B is not equal to A. In the next step, let us put the values. C is n plus 2. So this will become n plus 2 whole square. A is given as n and B plus A, n plus 1 plus n. It is like this. So this is n square plus 4n plus 4 is equal to n square that is 2 times plus n. So in the next step, n square minus 3n minus 4 is equal to 0. This is 0. So this will become n square minus 4n plus n minus 4 equal to 0. This will give you n minus 4 into n plus 1 is equal to 0, which will give you n is equal to 4 comma minus 1. Now since n is a natural number, you can't take minus 1. So the value minus 1 you won't accept. The value n is equal to 4 is acceptable. So the sides, determine the sides of the triangle. So you will say therefore sides are 4, which is n plus 1 is 5 and n plus 2 is 6. So this question was more about calculation, and you have to not apply much of the formula and techniques, but you have to directly apply the sine rule and cosine rule. Yeah, we have another question. In a triangle ABC, we define x is equal to tan b minus c by 2 into tan a by 2. Similarly, y is also given, as you can see here, and z is also given. It is a cyclic order. Then the value of x plus y plus z in terms of x, y, z is what of any one of this option. This is 2x, y. So now first of all, which formula you should go for? So as you can see, tan b minus c by 2, it is quite explicitly written here. So tan b minus c by 2 is actually b minus c by b plus a, b minus c by b plus c into cot a by 2. If you remember Napier's analogy. So by Napier's analogy, if you remember, we discussed, you can write this as b minus c by b plus c into cot a by 2 into tan a by 2 is multiplied to it. So finally it will become b minus c by b plus c, as cot a by 2 into tan a by 2 is equal to 1. Now x is equal to b minus c by b plus c, which implies you can write 1 plus x by 1 minus x as 2b upon 2c, which is b upon c. So 1 plus x by 1 minus x is equal to b by c. Now similarly you can say that 1 plus y by 1 minus y, if we will calculate, it will be c by a, and 1 plus z upon 1 minus z will be a by b. This will actually happen. Now if we multiply these three terms, that is 1 plus x by 1 minus x, 1 plus y by 1 minus y, and 1 plus z by 1 minus z, what will happen? So therefore 1 plus x upon 1 minus x into 1 plus y upon 1 minus y into 1 plus z upon 1 minus z, and this multiplication will be equal to b by c into c by a into a by b, which will finally be equal to 1. And what will happen on the left hand side? On the left hand side, this numerator will be actually 1 plus sigma of x in the cyclic order, x plus y plus z. Then you will get xy plus yz plus zx, which you can write short as sigma of xy. Then you will get xyz, one term. So 8 terms will be there, 2 into 2 into 2, 8 terms, 1, 3 from here, 3 from here, and then 1 here. Similarly in the denominator, you will get 1 minus sigma x plus sigma xy minus xyz is equal to 1. Now if you cross multiply, 1 plus sigma x plus sigma xy plus xyz is equal to 1 minus sigma x plus sigma xy minus xyz. So sigma xy will cancel and 1 will cancel, and you will write 2 sigma x plus 2 times of xyz is equal to 0. Now 2 will cancel and you will write sigma x is equal to minus xyz, which means x plus y plus z is equal to minus xyz. So x plus y plus z is being asked, it is equal to minus xyz. Which option is that? That is option B. So this is how we will prove it. We need to do some manipulation, because in the direct way it would be lengthy. We could have done by some direct way also, but it would have been lengthy. Okay, the next question here. In a triangle ABC with fixed base BC, the vertex A moves such that cos B plus cos C is equal to 4 sin square A by 2. If AB and C denote the lengths of the sides of the triangle as usual, opposite to the angles AB and C respectively, then B plus C is equal to 4A, B plus C is equal to 2A. Locus of point A is an ellipse. Locus of point A is a pair of straight lines. So let us solve it. It is saying that A moves, this A is moving and B, C are fixed, and the way in which it is moving is cos B plus cos C is equal to 4 sin square A by 2. So let us join this, and this is moving. So when you solve this equation, you can write it like this: 2 cos B plus C by 2 into cos B minus C by 2 is equal to 4 sin square A by 2. And here cos B plus C by 2 can be written as sin A by 2, because B plus C by 2 is pi by 2 minus A by 2. So we can write cos B plus C by 2 as sin A by 2. This will be 2 sin A by 2 into cos B minus C by 2 is equal to 4 sin square A by 2. So 2 sin A by 2 will get cancelled, and this is becoming cos B minus C by 2, and this is becoming 2 sin A by 2. Now what is sin A by 2? Again, sin A by 2 is pi by 2 minus B plus C by 2. So A by 2 is pi by 2 minus B plus C by 2. So you can do one thing, sin A by 2 will become cos of B plus C by 2. So this is 2 cos of B plus C by 2. Now let us apply the simple trigonometric identity of cos A minus B and cos A plus B here. So there will be cos A, which is cos B by 2, into cos C by 2 plus sin B by 2 into sin C by 2. And on the right hand side, this will become 2 cos B by 2 into cos C by 2 minus 2 sin B by 2 into sin C by 2. Now let us take this, let it be here, and take this on the left hand side. So this will become 3 sin B by 2 sin C by 2, and take this cos term on the right side. So this will 2 minus 1, 1 cos B by 2 cos C by 2. So this will become, sin by cos will be tan. So tan B by 2 into tan C by 2 is equal to 1 upon 3. Now what to do next? Now we have a half angle formula also of tan B by 2 as well as tan C by 2. So what we will do? We will apply that half angle formula, and tan B by 2 is root over S minus A into S minus C upon S into S minus B, and tan C by 2 will be into S minus A into S minus B upon S into S minus C is equal to 1 by 3. This is what we are getting here. Now, in the next step, we can cancel S minus C, of course, from here, and S minus B also from here. So it will be S minus A whole square under root, that is simply S minus A, and in the denominator S square under root, that is S. So S minus A upon S is equal to 1 by 3. This will give you 3S minus 3A is equal to S, which will give you 2S is equal to 3A. Now what is 2S? A plus B plus C. So from here, A plus B plus C is equal to 3A, which means B plus C is equal to 2A. This is one relation which is quite evident. So B plus C is equal to 2A, which is option B. Now what type of locus it is? Locus of point A is an ellipse or a pair of a straight line or something else. So B plus C is equal to 2A is actually, this is B, this is C, this is A. So this sum of the two sides is equal to twice of the third side. That is, it is a constant and it is greater than the third side. 2A is greater than A. So definitely this is locus of an ellipse, and this will form an ellipse whose B and C are actually foci, and such that the sum of distances from these two foci is constant, which is 2A, and greater than the distance between the foci, that is A. So this is how we can say that locus of point A is an ellipse. Now let us come to the next question here. If R is the radius of circumcircle of triangle ABC, prove the following formulae. First formula is A by sin A is equal to B by sin B is equal to C by sin C is equal to 2R, which is actually sine rule. And next one is R is equal to ABC by 4S. Again I am saying I will be taking this as triangle, because you should not get confused with capital S with a small s. Capital S means triangle area, a small s means semi-perimeter. So in printing it is okay, but when I am writing on board, a small s and capital S may look alike. That is why I am taking this capital S as triangle. So let us first draw the diagram of a triangle. This is ABC. This is its circumradius, circumcircle. This is its center, circumcenter. This is the two circumradius. Let us drop a perpendicular also on the chord BC. Now what we observe here, first of all, that the angle subtended on the segment is half of the angle subtended on the center. So if this angle is A, this whole angle is actually 2A. Angle on the center is double of the angle on the segment, or we also say angle on the segment is half of the angle of the center. Next, if this is 2A, this would be A, because these two are congruent triangles. When you drop a perpendicular from center on the chord, the two congruent triangles come up. And this distance is half of BC, which means A by 2. And this is R. So in this triangle OBD, if you see, you can apply sine A, which is perpendicular BD, by hypotenuse OB. Now BD is equal to A by 2 and hypotenuse is equal to R. So sine A is equal to A by 2R, or you can say that A by sine A is equal to 2R. So A by sine A is equal to 2R. Similarly, you can prove A by sine B is equal to 2R, and B by sine B is equal to 2R, and C by sine C is equal to 2R by taking this triangle or this triangle. Next thing is R is equal to ABC by triangle. So for the next question, we know that area of triangle is half AB sine C or BC sine A similarly. So this will become half AB and sine C. So what we will do here, that we will apply that C by sine C is equal to 2R. So sine C will become C by 2R. So this will become ABC by 4R, which is area of triangle, which means R is equal to ABC by 4 area of triangle. So this is also proved, and this is also proved. So in this manner you can prove this some formula. So this is a part of theory basically, but it is also a part of question sometime. So you can solve them. Next question is about x radii. So r1 upon s minus b s minus c plus r2 upon s minus c s minus a, r3 upon s minus a s minus b is equal to 3r, and you have to tell whether it is true or false. So let us see. So if we take about r1, this is triangle by s minus a, this is triangle by s minus b, this is triangle by s minus c. So this will become triangle by s minus a, s minus b, s minus c. Another one will also become same, s minus b, s minus c, s minus a, and next one also. So 3 times of this. So this will be the left hand side. 3 triangle by s minus a, s minus b, s minus c. Now let us multiply by s in the numerator and s in the denominator. So one more formula we have remembered in school, that area of triangle is actually root over s into s minus a, s minus b, s minus c, which is the Heron's formula. So using this formula, this denominator can be written as a square of the area of triangle. So this triangle and this triangle will cancel. So this will become 3 by triangle by s. Now what is triangle by s? This is small r. A small r in radius is equal to area of triangle by semi-perimeter. So yes, the left hand side is equal to right hand side. So we can say true, proved. So in these type of questions which seem to be little bit difficult or like little bit complicated, but these questions are quite easy, because if you remember the formula you can directly find the answer. So one thing is very common, that if you see the theory complicated, the question will be easy. If you see the theory easy, questions will be complicated. So be prepared accordingly. Next question, r2 r3 plus r3 r1 plus r1 r2 is s square by r square, true or false? So here again this s is capital S, so this is area of triangle. This is area of a triangle square by r square. So again r2 r3 will be area of a triangle by s minus b, and this will be area of a triangle upon s minus c, plus r3 r1 will be area of a triangle square by s minus c, s minus a, plus this will be area of a triangle square upon s minus a, s minus b. So this will be equal to area of a triangle square upon s minus a, s minus b, s minus c on taking LCM. So in the numerator here s minus a will come, here s minus b will come, here s minus c will come. So s minus a plus s minus b plus s minus c. So what will happen? This will be area of a triangle square upon 3s minus a plus b plus c upon s minus a, s minus b, s minus c. This is the area of triangle square, and this is 3s minus 2s. A plus b plus c will be 2s. So this will become s upon s minus a, s minus b, s minus c. Now let us multiply with s here and s here. So this will become s square. So this will be area of a triangle square into s square upon area of a triangle square in the denominator also. So this will become s square, which is square of the perimeter, semi-perimeter. Now we know that r is equal to triangle by s. So s is equal to triangle by r. So using this, s can be written as triangle ka square by r square here. So triangle square by r square, it is what we have to prove. So this is a true statement, and hence we can say that what we needed to prove is true. So in this chapter we have discussed few of the very important questions, and one more question is there. It is not complete. So let us discuss this one also. State whether the following statements are true or false again. So a cos A plus B cos B plus C cos C is equal to 4R sin A sin B sin C is equal to A plus B plus C R upon R. So what we can do, A cos A plus B cos B plus C cos C, we start from here. Now what is A by sine rule? A is A by sin A is equal to 2R, so it is 2R sin A. So 2R sin A multiplied with cos A. What is B? 2R sin B. So 2R is taken common, sin B cos B, then plus sin C cos C. Now let us multiply 2 inside everywhere. So 2 sin A cos A will be sin 2A, this will be sin 2B, this will be sin 2C. Now we know that in a triangle A plus B plus C is equal to 180 degree. A plus B plus C is equal to pi. So this is a conditional identity. And in trigonometry we remember this conditional identity. Even we can derive if we don't remember in 2-3 steps. But I am not deriving it. So you can write that this is 4R sin A sin B sin C. So the first statement here, 4R sin A sin B sin C, is true. This is true. But that is not enough. Another statement is also there which will decide whether the whole statement is true or not. So let us see A plus B plus C, small r by capital R. Again, A can be written as A by sin A is equal to 2R, that is 2R sin A. So I am taking 2R common, sin A plus sin B plus sin C into R upon R. Now this R and this R will cancel. Now again by conditional identity, sin A plus sin B plus sin C is 4 cos A by 2 into cos B by 2 into cos C by 2. And a small r, there is a formula for a small r which says that it is equal to 4 into capital R sin A by 2, sin B by 2, sin C by 2. So this becomes equal to 4R and 2 sin A by 2 into cos A by 2 will become sin A. What formula we are applying? Because 2 sin theta by 2 into cos theta by 2 is equal to sin theta. Sin A, sin B, sin C. So 4R sin A sin B sin C, this is equal to this. So this is also true. So we can say yes, the following statements are true. So hence statements given are true. So these were some of the questions which were for us to do, and I hope you have enjoyed it, and all the best and keep working hard. Thank you.